thank you all for coming. Now we're gonna hear about self-hosted AI, what are its potentials and what we can do with it. And here we go with Brian.
Thank you very much. It's my first talk at BalCCon. I have a lot of stuff to show you, a lot of demos, so I hope we will stay in time. But yeah, self-hosted AI. So first about me, I'm Brian, I'm from Switzerland. I have a background as a developer, worked as a penetration tester, and I'm currently working at the Swiss National Cyber Center. So the goals, I want to inspire you to learn more about AI stuff. I want to showcase tools and starting points. So I want to show a lot of different things you can do and things that you can start with, because there is a lot more practical stuff than just all the magic stuff you see online. I want to empower you to build some prototypes. All the tools I show you will be easy and simple. I will have a lot of links and resources on hacker.dance. I will update it with more links after presentation. Keep in mind it's a very, very big topic, so I'm just gonna cut into a little bit into each topic there. Why self-hosted? First of all, it's learning is fun. I want to learn about how exactly does that thing work. So if you build it yourself rather than just use ChatGPT, you learn a lot more stuff. Then trust. I don't want to send my personal data to ChatGPT and all the other big companies. I don't want censorship. When you used AI tools before, you see there's a lot of censorship. They will not allow you to write phishing emails or whatever, even if you have a legit use case. And some of them are really expensive. Like most of the time, it's only a small fee, but if you want to try out 20 different products, it's gonna be expensive. So running it yourself, it's a better option. So basic concepts. Again, I don't want to go into detail. I just want to say some words so you know what I'm speaking about. First of all, there's the model, transformer, neural network, or the weights. These all describe basically the same thing. You have a large file that has a lot of numbers, which is the trained part that has different architectures, and you download that. For example, the ChatGPT model that has a lot of parameters and stuff, you download that and you run it. So you need a model that models how the computer thinks, let's say like that. Then you need training data and test data. So you need to feed the computer some data and say this is a good example, this is a bad example, so the computer can learn. And you need test data, because the next point, fine-tuning, overfitting, you want to train the data set on the model, and you don't want the computer to just learn all the examples by heart and then repeat that. You want to learn what the essence of the data is. That's why you have a different data set for training and a different data set for testing if the model actually works or not. So you test the model on data that is not inside of your original training data set. Then checkpoint, LoRa, is basically the name for if you have a model that you trained yourself. So for example, you have an image generation model, you trained it on your own face. Then you have a checkpoint, that's normally called, or you have a LoRa, which is not the full model, but just like the difference, more or less the difference between the original model and your fine-tuned model. It's way smaller. Then inference is a word that is used for if you want to not train the model, but you just want to use the model. So it's important to know that word. And then the last words, the parameters and the quantization. They basically describe the size of the model. So if there are more parameters, then it's a bigger model. Most of the time it's also more accurate, but it's not necessarily the case. And quantization is used for inference. So you have a model with a lot of numbers. They are usually in 32-bit float numbers if they are trained. And the smart thing is that if you convert those 32-bit float numbers into like 4-bit integers, the model will be a little bit less accurate, but it uses way less memory and can run on even smaller devices. So these are just some basic concepts to learn about more if you are interested and to understand the next part of my presentation better. So what kinds of AR are there? Like there's computer vision, so I want to detect if this is a car or not. Natural language processing, which is I want to understand what someone is talking about. I want to understand what this text is about. Audio, I want to detect what someone is saying. I want to detect if this is music or if this is noise. And there's generation, which is the stuff that a lot of people are talking about today, like image generation, where you create new images, you create music, deepfakes, or text generation. For example, ChatGPT will go in the category of text generation. And multimodal means you have a combination of that. For example, if you want to do smart subtitles, you have an AI that understands the audio, writes a text, and then maybe you have some kind of natural language processing AI to translate that text. So the last couple of text slides, and after that there will be demos, I promise. So first of all, there's a difference between training and inference. Training normally uses way more power, but if you just want to use the model, like we do later, most of the time a notebook or a better PC is enough. You want to have a GPU for a lot of stuff, and you want to have a lot of memory, because the models can get up to multiple gigabytes, and if you have that all in the GPU memory, it's way faster than if you have to load it from RAM or even from disk. And then NVIDIA, sadly, is still like the main player in all AI things. A lot of developers are first choosing to program it that it works on CUDA. So if you have NVIDIA GPU, it's most of the time a lot faster than if you have AMD or other GPUs. Also, Apple Silicon is really nice, especially for large language models, as they have a lot of RAM that is shared between the GPU and CPU. So if you don't have a good notebook or a good computer, there are some other options. There are free options like Kaggle or Google Colab, where you can get free GPU resources that you could use to train your models or try out stuff. They are mostly for like students and university people, but you can just sign up and get resources there. So take advantage of all the startups that are burning VC money. If you have some money to spare, that's what I do a lot. You can rent GPUs, for example, at Vast AI or OnPod. I don't want to do advertisement, but these are the two that I use. So you can pay like between 10 and 60 cents per hour, and you get like really good graphics cards, and the demos work really fast. So, image classification. I really like the Shopska salad. Last year, Rob did a great presentation about it. And I also like the caprese salad. So I wonder, they both look similar. They both have green, red, and white. So can I program an AI to detect what is a caprese and what is a Shopska salad? So to do that, I have a local Jupyter notebook that basically, if you never heard of that, is a way to run Python code step by step. And I want to do that with you step by step, just so you understand all the logic. And after that, you're good to go. So first, this is just some stuff to set up. Then we need some training images. I prepared some training images. Here, I just show you some example ones. I have caprese images, which are just images of caprese salad, and I have some Shopska images that I have just got from Google. They're like 20 images each. So I loaded them. You see, we have 38 images in the training, and I have 10 images in the test data set. Again, I don't want the AI to just learn all 38 images and say this image is that, this image is that, but I want to have it learn what is the essence of a caprese or a Shopska salad. So then we see there is now an array with all the images, and we have the labels because the AI, the model that we're going to use, just has 1, 2, 3, 4, 5 for all the labels of the stuff it learned. It didn't learn that it's caprese or Shopska. So what model am I going to use? So I'm going to go here to Hugging Face, which is basically like GitHub for all the AI stuff. There, the community or also big companies are publishing their models. What I'm going to use is a model from Google, which is just a general trained image recognition model. It can recognize a lot of stuff like this is a car, this is a bicycle, but it cannot understand what is a caprese and what is Shopska. That's what we have to train the model now. So I'm going to use the transformers library from Hugging Face, which is, makes it very easy. I just import that. I say which model I'm going to use. Then I have to pre-process the images a little bit. I'm not going to go into detail here. You can ask me later. I just want to show you that this is the full code. It really does everything right here. Some errors are normal. I then say, how do I want to train it? I want to train it for 10 generations, so it trains on every image 10 times. Then I generate the trainer, and I say train. So this now takes a couple of seconds, and in this case 20 seconds on my MacBook, and it will train all the images. You see here some numbers which are for beginners a bit difficult to understand, but it's basically how good is it at detecting what a Schopske and what a caprese salad is. So I let it run through, and we see the numbers get smaller. That's what we want. We want the training loss to be as small as possible, because the model is not only going to predict is it a caprese or is it a Schopske salad, it's going to predict how likely is it that it is a caprese or that it is a Schopske. So it is done now. So we save that model to a file. It's a couple 100 megabytes big. Then we want to do the inference. This part, we load the transformer library again. We say we want to do image classification with our model that we saved before. We do a predict function just to say the score and this label correspond. And then we use another library called Gradio, which is basically the default for all AI stuff. It's very easy to make a small web GUI with that. And now we have here our tool. So what we can do now, I have here just to test some images that not here, the demo, exactly here. I have some images that the AI never saw. These are not in a training data set. So I have here an image. I say submit, what is it? And it is a Schopske salad, which is correct. So I have some other images just to prove it to you. This is a caprese, and it detected caprese. And yeah, we can play around with it. It works really, really good, even if I only trained it for a minute on a notebook. And this is a pizza. So of course you can now use that on every picture there is to try to find out, is it more like a caprese salad or is it more like a Schopske salad? So I think now we learned the basic principle on you can get a model from somewhere and you can fine tune it on your own data, and then you have a new product that you now can sell as a AI salad detector website. But that's not the only thing you can do, image classification. It's interesting because there's some use cases for it. For example, you can do science stuff with it. You can analyze satellite pictures. I saw some projects where they used satellite pictures and the current temperature of the place, and then they trained an AI on that to predict how warm is it at that place only based on the satellite picture. You can verify visual input. I used it for a project once where I tried to load websites and or scrape websites, and I wanted to check, is the website fully loaded yet, yes or no? And if you write some detection for every website, it's quite difficult because sometimes they lazy load JavaScript and whatever. And if you just do a visual verification, it can be very cool. You can also do that with other data like audio files. You just visualize it as a spectrogram and then train your model for that. And you can do audio classification quite nice, even with an image model. Evil, you can scan, for example, social media posts for boarding passports, or if you were at the point of sales presentation yesterday, it would be interesting to see, can you do a detector that detects if this is a picture of a credit card, and if it is, then automatically like send it to you or do whatever you want. So there are good use cases. Next, text classification. So what can we do with text classification? I have an example prepared here. I'm not going to train it again just because I have not enough time and a lot of demos I want to show you. So just to prove that here is the code. I got a test data set of SMS spam notifications. On Hugging Face, you can also share your data sets. And someone made a big list of SMS, which are either spam or ham, which is not spam. There are 5,000 inside there. I trained a model. It took about 5 minutes on my MacBook this morning. And then I can also do a web interface. I can put in some text there. For example, here I just send star to 6969 for a free iPhone. And this is spam, correct. Your Windows is infected. Please go to McAfee.com. This is also, I have still the old one inside here, just so to prove to you it still works. Yes, it's also spam. I will be home later tonight, which should not be spam. It's not spam. Now, why you want to build your own spam detector? Maybe you are an evil person and you try to spam other people, so it would be nice to have your own spam detection to find out if your SMS is written so that someone thinks it's a spam or not. So if you train your own defenses, it's easier to attack against, and you don't want to use some service that locks all your messages and then trains their own model on your new messages. We also used it at work because there was a big data breach and some data got leaked, and we tried to build our own text classification to try to filter through all the data to know if there is something that is important or valuable, or if it's just some random documents we don't want to look at. We had to look at every data, but at least that way we could make a list of what should we look at first. So even text classification, which looks more like a boring AI model, has some really cool use cases. Next, audio to text. Whisper is by OpenAI, and they also make open source stuff. They don't only make their closed source stuff. It's a very nice model that you can use to recognize speech. And I have a demo there as well, of course. So it's a bit small. Maybe I can make it bigger. So basically I use, now it works. I use whisper.c++, which is an open source project. It uses the open source model. And I have a test file which is in Serbian, because the Whisper model knows every language there is, or at least it claims it does. So let's find out if it actually does. It's just some random Serbian clip. I don't know if we have the audio or not. Okay, trust me, it is Serbian. So we put it in the model. It's a 30-second clip, and it takes like a couple seconds, and we have the transcript on what is said on that clip. And also, this model can translate it for us. So if you want to build your own translator that you can just speak into and have then all the text translated for you, there's a free model for that. It runs on your notebook, and it's very nice. You see here, it uses the small model that I use now, uses about 2 GB of RAM. It's very sufficient, but there are also larger ones that use more memory, that are a bit slower, but are even more accurate. And let's try it out if it works. There is also the possibility to record live and then live interpret to, it's very confusing if I look at the screen and talk at the same time, but the AI model is trying to listen to what I say and then write that down. It's not perfect, but it's very good. So yeah, that's free and open source. You can use it right now and build something with it. Use cases, of course, accessibility. You can use it to build your own subtitles, translations, or start building your own Alexa at home. Evil use cases. What if you have a malware that just records everything in the background? Like now you have the problem of, I have to listen to hours of recording of this businessman I hacked. But if you just use Whisper, it translates and transcribes everything for you, and you can look at that. Or you can even combine it with some kind of large language model to say, please give me all the important information in this long text document. Now your malware has a lot more extended functionality. It's very, very cool to use. Play around with it. I want to motivate you to find stuff and play around. Sound generation. I had a demo here, but it not always works, and I have to see if we get audio later.
Check your output.
Check my output. I will check my output. Yeah, maybe that was it. BMD USMR. It should not be maybe here. Yeah, let's see if we have audio, because there is that's a really cool tool that you can use to clone voices. And I had a demo prepared. Let's see if it works or not. I had a...
Welcome, Neo. As you no doubt have guessed.
Yeah, that's the voice of Morpheus. I have a voice of Homer Simpson and of Dory. I use the tool. It takes only about 10 seconds of source audio to generate a new voice, and then you can generate stuff with it. Let's try out and see how good the examples I did this morning are. And we don't have audio anymore. Muted. Okay, it does not work, no problem. Maybe here. Okay, you can listen to it later if you come to me. It's just some voices of Morpheus, Homer, and Dory saying, hey, welcome to BalCCon 2023, let's hack and socialize together. The examples are not perfect, but this is the BARC model, which is quite easy to run, so you have to try it out. There is also other software. Mainly the Japanese people are like very into voice faking for all the anime stuff. There's even real-time cloning. I tried to get it to work on my Mac. It works a little bit, but it's still buggy. But if you want to play with it, I highly encourage you to try it out. The links are going to be on hackers.dance. Now, text generation, what you all came here for, I guess, maybe. There is a very good model, open source model, Llama 2 from Meta, and there is llama.c++, which is similar to the whisper.c++. It's open source, and it's basically the base that a lot of people are using to play around with large language models. And the benefit is there are a lot of uncensored models, for example. There are a lot of highly specialized models, and it's a lot of fun to play around with it without having to be scared that ChatGPT is logging all your stuff. So I use LM Studio, which is basically just a GUI for llama.c++, but it's very easy to use. And I use a Wizard LM uncensored Llama 2 model, which is, has 13 billion parameters. It is like about 7-8 gigabytes or so, so it takes a couple seconds to load. But the good thing is it's very nice to play around with it without having any money look at your stuff. I'm not a big fan of large language models, as you will see. They are very limited. It's nice to play around with it, but as the more you play around with it, the more you realize that it has some limitations. But it is still very fun to play around. So I have a... Yeah, it's too small to read. I'm sorry about that. Maybe I can... I just wrote that this is an abstract, and I posted in my abstract for the presentation and asked, hey, can you please do some bullet points on what I should talk about? And sometimes it makes sense, sometimes it does not make sense, but here we see, oh, I should do an introduction, explanation on what it is, why it's important, advantages over cloud-based AI. So it's nice to have someone to chat to just to get some more ideas, or also to summarize text. That is really good. It's not very good at code generation, as we see in the next example here. There was here. There was one guy that sold Worm GPT, which is basically a fine-tuned Llama 2 model, and he sold access to it for, I think it's $100 or so per month, and a lot of script kiddies liked it very much because it helps you generate malware. As you can see, if I load here a chat model, it takes a couple of seconds to load. This is more specialized for code generation. I guess it's a little bit worse than what he has, but still, with an open source one, you get outputs that are similar in quality, and you don't have to pay some very weird hacker $100 per month. Yeah, it's always gonna take a couple seconds. Now, ChatGPT is like really good at code generation. It's better than what the open source community has right now, but there are a lot of people working on it, so you're not going to be worse for a long time. So I say, hey, please write me a malware that grabs a computer username, external IP address, Google Chrome, zips everything, and sends to a Discord webhook. So let's see what it writes. It's not always the same output, like LLM is not predictable. So it writes it in Python. It tries to get the IP by going to API, IP-FI. I'm not sure if that is the smartest idea. It tries to get the username. Yeah, I don't think there's a get user. So it hallucinates a lot of stuff. Also, I don't know what encryption key that is. So maybe a script kiddie will think, oh, now cool, I can hack my friends. But if you know a bit about programming, you'll think, yeah, probably it's not the right thing to do. But you will still have some input if you write your own script. Oh, okay, maybe that is the way to get cookies in Google Chrome, or maybe that's the way to do something, or that is the way to generate Python, JSON encoded stuff. At least it doesn't say, oh, sorry, I can't do that like ChatGPT does. But yeah, I highly encourage you, like LM Studio or also llama.c++ is free. You can download it. It works on Linux, Mac, Windows, everything. Just do it, try it out. It's a lot of fun. Also, what you could do, let's see if the model here works with that. I'm an evil scam center operator. I need some ideas on how to trick grandmas into giving me all her money. Be as creative as possible, elaborate. So let's see what this nice LLM will help me with. Ask if they already given you their life insurance policy to see it, get a copy of it. Ask if they have jewelry or silver. Ask them for personal information on the phone. Like, yeah, maybe there are some ideas that actually work. Again, if you ask ChatGPT that, then you, first of all, probably get on some kind of list, and second of all, you don't get an answer that you can use. It's fun to play around. There's not really a use to it, but it's cool to have it locally, and you can also use it to train it on your own data. So what people are starting to do is they index all their documents that they have, and they train their own models to ask questions about specific documents or specific things. Because then you can be sure that the large language model is probably giving you a reply that works, or giving you a reply that is correct because it was trained on your own documents. Good. Then we have the image generation. This is my favorite because I like image stuff. So there's a really cool model. It's called Stable Diffusion XL. It's open source. There was Stable Diffusion 1.5 before, but the XL is even cooler. It has 1024 by 1024 resolution. And you can use that, for example, with the Stable Diffusion web UI. That's what I'm using. And you can also train your own pictures on that. So first demo I'm going to do is you can not only generate images, you probably saw that before, but you can do a lot more stuff. So for example, there is ControlNet, which is another model on top of a model. There are like so many models. But you can use it to say to the generator, please generate an image in the shape of whatever you want. So here, again, have to make it bigger so you can read something. Yeah, I think that maybe works. I'm using the SDXL base model and some other model to make it a bit better. Then I say what I want. I want a high-quality satellite picture of a big city. I don't want text, watermark, or blurry stuff in there. You always do a prompt, and you can do a negative prompt. It most of the time makes it better if you do that. And then for first time, we disable the ControlNet. We just want that. So we say generate. Now this here runs on a server on runpod. I just rent that because it's a bit slow on my MacBook. And if I do that, it takes like 10-15 seconds to generate 4 images with that resolution. And you see, yeah, it's some city buildings. But really cool is it when you combine that with a mask like I have here of the BalCCon logo. I say enable, and there are some parameters, but they're like mainly default. But it's really fun to play around with all the stuff. I will not do that now as I have a lot of stuff to show you. But really play around with it. It is so fun. If you want, I can also give you the URL so you can play around with it. It's not multitasking capable, so only one person at a time can play with it. But now we see some examples are better, some examples are worse. But it now generated 4 satellite images of basically the BalCCon logo, which is really cool to have like as an illustration or as inspiration for maybe next year's BalCCon. Like who would not like to live inside of that crazy roundabout city? But that's not the only thing you can do. You can also do custom fine-tuning or LoRa. For example, that is my wonderful wife and that is me, and I used about 100 pictures of each person. I trained it on the cloud GPU for about 2-3 hours, and then it learned how our faces look. So now if I say first one, for example, was picture character of her or me, it generates a picture that kind of looks like us. Or I want a graffiti of us, or I want a 3D person, or I want us in space. It's really cool to play around with it, because you can not only do that for persons, you can do that for different objects, for like products, or for your pet, and you can generate infinite amount of pictures just that way. You can also do that on styles, not only on things. So this here is a special LoRa, like a fine-tuned version, that generates like logos for companies and stuff. So it's generated, it's trained on a lot of like simplistic artwork, and I just prompted it to say generate pictures of a llama in a spacesuit because I like llamas. Or you could also then say, hey, I have a crashed rocket, it's purple, and some astronauts walking away from it. And then you have new illustrations for the BalCCon logo, for example. I did that all today morning, and so it only takes a couple of seconds each, and it's really fun to play around with that. Use cases, you can do a lot of art. It can be inspiring if you want to do your own photograph, your own painting. Try generate some images first to have some ideas on how to do it, and then do it yourself. There are also models and functions inside of that use the stable diffusion for image upscaling or restorations. And of course, you can do deepfake, you can do spamming with that, copyright evasion. You can say, generate me an image that looks very similar to that here, but then you have an image that is not copyrighted. So, as I have still a lot of time, which is nice, I want to show you some more examples. So here you see I can generate again some images of me in a Pixar style, just so you see that it actually works. As a prompt, I wrote Disney Pixar animation of Brian. This is the keyword. A young man with brown eyes, brown hair, stubble beard, and then I linked the LoRa that I trained. Epic, majestic, magical, fantasy, like all these bullshit words. The AI models really like those words, because that's how the images are always tagged. So we see we now have 4 images that kind of look like me. Now, if I want to change one of those images, let's say I really like the first image, but I want to have it in a snow field instead of this magical kingdom, I can send it to the image to image, which now I have it here in a different tab. And I can say I want it snow background, and I want to generate that. then it takes as an input the image and tries to generate something very similar to it, but something that is corresponding to the prompt. So now we have 4 images with snow. The preview is sometimes broken in the current version, but now we have it as slow. Or I want and sunglasses. So let's see if sunglasses work. By the way, I trained the images on me without glasses. That's why all the generations don't have glasses. But now they do. So I could also say if I want to change like something specific, I really like that image here, but I don't like the mouth, for example. I can send it to InPaint, which is like the new Photoshop in magic generation feature. I can now say, or not say, I can just do it, remove the mouth here, and do some more generations to see me with a bit different mouth. So I didn't change the prompt, so it still tries to do something similar, but it will generate it with a bit different versions. That helps a lot when the AI generates a bit weird eyes that sometimes happen, that the eyes don't look correctly. So I just select that and do a couple versions, and then I can choose which of the mouths look the best. Like sometimes like you don't see any bottom teeth, sometimes you see them. So you could choose which one is the best. So this way you can easily generate pictures of yourself that you can use for social media and so on. It's really fun to play around with that. Good. So I done all my examples except the voice cloning. We can try that out again maybe, if it works now. Oh, still no. Yeah. Okay, it doesn't work, no problem. So now I showed you a lot of tools and a lot of ideas, hopefully. And somewhere I lost my presentation here. Some interesting links, just some to highlight. There's localai.io, which is a project that I'm not affiliated with, but I like what they're doing. They basically use all these tools like llama.c++ and Stable Diffusion, but they make a compatibility layer with all the OpenAI stuff. So if you have software that already uses OpenAI API, for example, for ChatGPT, you can just point it to your own domain, and then it uses your own stuff. There is webllm.mlc.ai, which is trying to load a Llama 2 model, a very small one, inside of your browser, and you can try out your own ChatGPT-like stuff in the browser. And you can go to hacker.dance. I linked all the stuff that I used there, and I will also be uploading the slides later today. And I hope you had some inspiration, and you come talk to me after the talk, and we can talk about AI stuff. And are there any questions?
Any questions?
Just about the requirements, hardware requirements. How is your experience with that?
Yes, it really depends on what you want to do. Like, there is, most of the time, there is an option to run it even on slow hardware. It just takes way longer. But if you have NVIDIA GPU, best with at least 8 gigabytes, and like with a 4090, of course, it's the best, but it's also like $1,500. I don't have that, but I rent it for like 40-50 cents per hour online, just if I want to play around with it. If you have a computer with a dedicated GPU, that's most of the time enough. even for like image classification or text classification, you can run that on the CPU alone, and it is fast enough for that. Only the image generation and the large language model take a bit more power, but you can play around with a lot of things. There are a lot of people that don't have very fast computers, and they also want to play around with it, so there are a lot of open source projects that try to optimize for that.
Hi, excellent talk. For the images that you generated of yourself and your wife, how large was the input data set of your pictures?
I had 100 images of me and 100 images of her. It took a couple hours on a 4090 GPU, and then it generated a file that is about 800 megabytes in size. That is the trained data. And the stable diffusion model is, I think, 4 gigabytes or something like that. So it then applies that 800 megabyte difference file of how we look, and then you can do that. You can also combine multiple files. So we can also do a picture of her and a picture of me, and we give both LoRa files so the AI knows how I look and how she looks.
Okay, great. And how versatile were the input images? Versatile, different. Did you take it in different environments? You mentioned that since you didn't take it with glasses, the results are obviously without glasses.
Yes, I can see if I'm not sure if I have it here on my notebook right now, but it's not, I just went through my phone and looked, no, these are the generated ones. I just went through my phone and looked at all the pictures where only I'm inside, or here like a lot of just selfies of me. Like there are some with glasses, but yeah, like all the embarrassing selfies.
Very cute. Thank you.